are important.
Resources are very important. You got that right. All right. Hey there, SWT. Hello there, Willy Blue. Hey, Kelcoin. And hello, BZ. BZ, I saw your messages, but I didn't get to look at them before this, so I'll take a look after. Let me go ahead and start the event. Oh, great. My headphones are broken. They only work in the right ear. That's triggering. That is very triggering indeed. Oh, I just realized you can hear my coughing on the stream. That sucks. The last 2 to 3 days, I have gotten used to hearing your voice in 2 times speed. You sound so slow right now. All right, well, I'll try this. The last 2 to 3 days, I have gotten used to hearing your voice 2 times speed. You sound slow right now. How's that? Perfect. Nice. Hey, what's up, guys? We're going to be learning about resources, and it's very fun. Maybe I'll do the whole lesson like that.
You're actually pretty good at that, Jacob.
Well, you know, I feel like I naturally talk really fast. And when I'm recording myself in YouTube videos or I'm doing streams, I I'm constantly telling myself in my head to slow down.
Oh, wow.
Yeah. Like, to me, this is me talking like very slow. Yeah, you speak very fast. I know, I do. All right. So yeah, as always, we're just gonna give it a few minutes, and then we'll get going with some super cool stuffs. What's up, Nicely Ice? Good to see you again. Snowmobiles, hey, first time. Good to see you. Not fast enough for PZ. True. I'll talk in 2 times speed so that he hears me in 4 times speed when he speeds it up. Yeah. So who's pumped about the Minecraft event, huh? That's exciting. Yeah, happy to have you, Snowmobiles. Also, I love your name. Never played SWT. Oh my, how? I feel like you would like it, SWT. Oh my gee. Yeah, I feel like you would like it.
Speaking of Minecraft, the new Quest Craft is one of the most popular VR titles right now on Quest. I really think NFTs and VR have a strong future together.
I haven't heard of that, Support Monkey.
Yeah, what, you haven't heard of Minecraft and VR, Quest Craft?
No. Well, now I'm curious. I gotta look into that. Wow, look at this. Is this like a Microsoft thing, or?
It's like a sideload thing, so that you can port Minecraft into a version that will work on a Quest.
Oh, that's dope. Wow. That's super cool. All right. Cool. All right, we can get going here. So, yeah, so I'm just going to recap a little bit about what we did last time. So, also, by the way, if I sound a little bit out of breath, it's because I just came back from a soccer game and we got our butts kicked. So, yeah, still sad about that. But anyway, so, yeah, so last time, let's go to the Flow Playground. We were talking a lot about structs. So if we open up a sample contract here, you know, we always start from nothing. But, you know, a struct looks something like this, right? So public struct, we'll call it like a container. And you can put some stuff in here, right? So you can put like, you know, public let thingy is a string. Public let number is an integer. You know, all these things, right? And you can, you know, you have to put like an initializer in here as well. to like, set this data. So it's basically just like a container of data that we can work with. And in previous, like in the previous workshop, we were talking about how, like if we wanted to make like a profile, we could put like a first name, a last name, and, you can even put functions in here, like public function change number, right? And you can pass in like a new number, that's an integer, and, it does something like self.number equals the new number, and, something cool like that, right? So you could change, this struct however you wanted to, and you could pass data around in this cool container. And if you've coded before, you probably have already seen structs a lot, but this is just sort of like a review of what we went over last time. So today, we're going to be talking about resources, which are probably the most important thing we're going to learn in the whole workshop, because Cadence is a resource-oriented programming language. Now, it's not that common to see something like this. In fact, I've never even coded in another language with resource-oriented programming. So it's sort of native to Cadence, and what makes it really powerful, especially as like an NFT type language. And in my opinion, it's why Flow and Cadence sort of latch onto NFT so easily, and why, Dapper Labs and NBA Top Shot and now their new NFL thing. It's why I think a lot of that took off, is because of how cool resources are in Cadence. So yeah, we're gonna go over what resources are. So start from square one. Oh, and by the way, just to mention, this is the beginning of chapter 3. So in last week we went over chapter 1 and 2. Today we're starting from chapter 3, day 1. So this is where I'm starting right now. So very similar to how we sort of declare structs, we declare resources, very similarly, right? So public resource, you always use public, you never use anything else. Public resource, and we're going to call this like test resource or something like that. And inside of here, actually, you know what? Why don't we just call this an NFT? Let's just do that, right? That's fun. So we're going to put an NFT in here. And it's the same thing as a struct in that we can put some certain data inside of here. So let's put like an ID field. So public let ID, let's make that an integer. Let's put public let name. This will be a string. And we can put public let owner is an address or something cool like that. So let's go ahead and initialize these things, and then we'll talk about why this is different from something like a struct. So let's say self.id equals, we're going to pass in an ID here. We're also going to pass in a name. And as all of you know, I like to make my variables have an underscore in front of them when they're in the init function. And then owner, but you don't have to do that. Owner is going to be an address. We can say self.id equals ID, and self.name equals name, and self.owner equals owner. So cool stuff, right? Pretty simple. So what did I do wrong here? I think it's just being really glitchy. Hold on one sec. Okay, I copied that, right? Okay, thank God. Yeah, so wait, what the... Oh, yeah, I know why. It's because, this is a really weird mistake, but basically resources implicitly have an owner field, so you can't put that again. So let's just say like holder or something, just to make it so it's not conflicting. Holder. Okay, cool. All right, sweet. So let me just make sure that's okay. Awesome. So this is, right now, this is very similar to a struct in that it contains some data. We initialize that data in the init function. Nothing's too out of the blue here, right? Hold on, I just want to make sure there's no background noise. Okay, cool. So why is this different from a struct? Well, let's actually go ahead and create a resource and see why it's so different. So public function create resource. And this is going to, I don't know, let's just return an NFT here. So right off the bat, look at what's different about this, right? I'm returning a resource type. Now, what did I put in front of it? I put this little @ symbol. And that's because this @ symbol represents a resource. So, if we had made a struct, let's say public struct test struct, like that, we would return, the type is a test struct. And let me actually make this bigger so you can all see it. We would return a test struct like this. But with a resource, you have to make sure you put the, @ symbol in front of it. And that represents that this is an actual resource that we're dealing with. Cool. So that's difference number one. We use @ to denote a resource type. Awesome. So then the next part is how do we actually, create this resource, right? If it was a struct, right, we would just say, let thing equals test struct, and that would be it, right? But with a resource, it's very different. And there's two reasons. One, it's because you can't just say equals, right? And actually, you know what? Let me get rid of this now so we don't see any errors. So with a struct, we can just say equals. But with a resource, you'll notice we can't say that, right? We can't just do NFT. It doesn't work. You can't just pass this in. What we have to do with a resource is, in order to move it around, we have to use this arrow syntax. So you do this little thingy and then this, the dash. And this means that we're going to take this resource and we're going to move it into this variable. So it's very different, because a struct, you can just say, you know what, we're taking this variable and we're going to make it this. And then on the next line, we could just do that again, right? We could just make it something else. We could just make it another NFT or something like that. But with a resource, you have to explicitly move your resources around using this arrow syntax, right? And the second thing is that you can't just say NFT. You have to say create NFT. And then, of course, we have to pass in some, the example, like the variables right here. So we could say, like, ID is 0, name is, BZ, and holder is OX01 or something like that, right? And then, so that's how we actually create the NFT. So you have to, use this arrow syntax and then use the create keyword. And then the rest of it is just like a struct, right? So we don't, that's what it looks like right now. Now, you're going to notice that we actually get an error here, and it's saying loss of resource. So whenever you see loss of resource, that's because Cadence is telling you, hey, programmer, you forgot to do something with this resource. And that's where, this brings us to probably the most important concept in Cadence, is that resources are very different from structs because you have to make sure they always go somewhere. So there's three options for them to go. You can put them inside of another variable, you can put them inside of account storage, or you can destroy them. But you're not allowed to just leave them dangling like this. You have to make sure you put them somewhere. So what we can do is we can just immediately destroy it right after. And you see all the errors go away. Now, what does destroy mean? Destroy means take a resource and just blow it up and say, you know what, it no longer exists. But this proves that we have to make sure that we are explicitly saying where this lives. So also, let me make sure, I'm going to put this text on the side so that I can see all your chats. Okay, cool. So, by the way, if you have any questions, make sure to let me know. So someone else says, is that what burn mechanisms do? So that's a great question. Usually when you think about like a burn mechanism, you think about like fungible tokens, like flow token and stuff like that. That's usually where the term burn comes in. But definitely, if you wanted to quote unquote burn like a NFT or resource, that is exactly what happens. So you would take like a fungible token and you would destroy it, and that would burn the token. Exactly. Yep. So yeah, that's what we would do. So why don't we now, let's, instead of destroying it, let's actually return it. So what we can do is we can add this back. So we're going to return a @NFT type, which is just a resource. And so we can do that. So let's return, and then notice, why can't I do this? Can someone tell me what's wrong with this? Gold star to whoever can tell me what I have to add to make sure this is right. Remember, we have to, exactly, BC. So we have to move it into the return value. With resources, you always have to make sure you're moving them into a certain spot. So I want to pause here and talk about some things. First of all, we can already see that resources are pretty different from structs, right? Because we have to be extremely explicit about where we're putting them. But the other thing I want to talk about is that this ties into the general theme that Cadence is very readable, right? When you look at this smart contract and you're reading this code, you know exactly what's going on. You know we have a variable named thing, we create an NFT, and we're moving it into thing, and then we're moving it into return. This is very different from other languages like Solidity. You guys know I love to trash on Solidity, but it's true in that Cadence is a very readable language and is very secure, right? So you can imagine that if this NFT was worth $1 billion, right? And the smart contract developer accidentally wrote this, that wouldn't be good, right? Because we would create the $1 billion NFT, we would leave it in a variable, and then it would just get lost in the sauce, right? But if it's yelling at us and saying, hey, you have to do something with this resource. So it's impossible. It's literally impossible to lose your resource unless you explicitly destroy it. So you literally type into your code destroy, right? So it just goes to show that resources are much more secure and help the programmer understand where they're supposed to be. Now, one other thing I want to mention, let's try to do something else. So let's try to do thing, and let's try to put another NFT inside of it. God, this thing is so annoying. Hold on one sec. How do I get rid of that? Okay, hold on one sec. So if I do this, right, and do thing and try and do that, look what's happening. It is, oh, well, cannot assign to constant. That's not, okay. So it's giving us an error. So look at what's happening here. You know, I'll just zoom out for a sec. Look at what's happening here, right? We put something in thing, right? So a resource is currently in here. And on the next line, we try to overwrite it. That also is not allowed. So you're not allowed to overwrite a variable that contains the resource, which is also really important, right? Because what if thing contained $1 billion Bored Ape, right? And on the next line, the developer accidentally put a new create function and tried to overwrite it. Cadence won't let you. So you have to be, you know, it's very easy to Cadence makes it very hard for you to mess up, which is a really good thing, right? Cool. So that's that. There is our resource. Cool. So I believe this covers a lot of what we talked about in day one, and what I really wanted to show you in here. So yeah, so it looks like I pretty much covered everything I wanted to show you. Of course, you know, Jacob rocks. True. Yeah, obviously. Cool. Yeah. So that's day one. So we can move on to day two now, which is mainly talking about, you know, resources in dictionaries and arrays, which is where things get a little more complicated. But before we do that, let me show you an example of actually creating this NFT in a transaction and then just reading some of its data, right? So let's go ahead and deploy this. Deploy to an account. So let's go to a transaction. Let's go to, you know, let's import test from OXL1. And let's go right here. So let us say, and when we're done, let's just log like done. So we just know that it's finished. Okay. So let's go in the execute phase and let's say let thing, and let's move in a test dot, and let me actually refresh this page so it gives us auto completion. So test dot create resource, right? And look what happens. So we call test dot create resource, and remember, I'm not doing equals. I'm moving the resource into thing, and then, you know, it's saying loss of resource. So let's go ahead and let's just log thing.name or something, and then let's destroy it. Just like that. So let's send it. And look, so it logs BZ and then done. So this is just an example of creating a resource, moving it into a thing, and then logging like a name about it, and then destroying it, right? Super cool stuff. Boom, we did it. So does anyone have any questions about this so far? All right.
If we didn't want to destroy it, let's say I wanted to log all of the things that you had, would that execute loop be like, instead of destroy, just move it back from whence it came?
That's an awesome question, Swarm Monkey. So we're going to be, in the next part of this lesson, we're going to be talking about where we can actually put this thing instead of destroying it. Because right now, you know, we're creating it in the contract, we're moving into the transaction and then destroying it. But there's two other options, which is what we're going to talk about next. One of them is storing it inside of like a array or dictionary, and the other one is storing it in account storage, which is by far the most common. And we're going to talk about account storage later this week. I believe on Wednesday, on Friday, or maybe next week. But yeah. So what I'm going to show you now is storing it inside of somewhere so that we can actually do something with it. So yeah, sorry, I know that it's like a very broad answer, but basically the answer is we're getting to that in a sec. Cool. So, quick sanity check, by the way. Oh, so I didn't really explain this, but the other thing about resources that's very different is, let's actually go into a script right now and let's try and do something cool. So let's delete this, and let's import test from OXL1, and let's just refresh for a second. Okay. So let's go ahead and let's in this script, let's try and create a test struct, and let's try and create an NFT resource. So let's say let thing equals test.teststruct, right? Okay, I think it's being weird. Yeah. So this is allowed, right? This works. But what happens if we try to do this? Let thing2, and let's move in a test dot create resource. Well, okay, well, oh no. let's try and do, hold on, I didn't mean to, okay, so let's say in this example, we didn't have this function here, right? Because this, what I'm trying to show you is that there's a struct, and then there's a resource, right? So if we deploy this contract, go to our script, and let's try and create a resource here. Create NFT, create test.nft. It's not allowed. And the reason for this is because this is another difference between structs and resources, is that structs can always be created outside the contract. So we can create a struct in a transaction, in a script, wherever we want. Resources can only ever be created inside of the contract itself. So that's actually why I added this function here. Oh, of course I can't undo it. But this is why I had to add this function here to show you all these examples, is because it's impossible for us to get a resource out of the contract unless we actually create it in a function and have this function be publicly callable to the public. So that's why I did this here. So hopefully that also shows you like a little example of why they're different. So let me just go ahead and add this function back. Okay, cool. So this function is back and better than ever. All right. So what I'm going to show you now is actually storing these resources somewhere so that they don't just get lost and we don't just destroy them immediately. So this is going to be chapter 3, day 2, about storing resources in dictionaries and arrays. All right. So let's go ahead. Let's just get rid of the struct because we already talked about the differences between them. But let's go ahead and let's do a public variable, and let's just say like, you know, list of resources, right? Resources. And this is going to be a list of resources. Now, right off the bat, you can see there's something wrong here. It's saying missing resource annotation. So you might think that, oh, we just add this right here like that. And that this is wrong. And the reason this is wrong is because even though I did tell you that, you know, the @ symbols, it has to go in front of a resource, you might be saying, Jacob, you're lying to me. Kind of. And that's because with an array, you have to put the symbol in front. So you have to put the symbol here. And that's because you're saying, hey, Cadence, this is an array of resources, right? So you have to put this little @ symbol in front. And then, you know, we obviously have to initialize this in our contract. So we have to say self.list of resources. And remember, we can't just do equals this, because even though this isn't like a singular resource, it has to do with resources. So we have to move it. So anything that has to do with resources, you have to always use the move, okay? So that's why we move this little thing in here. Even though this itself is not a resource, this type is a resource type. And so we have to use the move syntax here. All right. So instead of creating a resource and then returning just a singular NFT, let's actually just not return anything, and let's store our new resource inside of the list of resources. So let's go ahead and say self.list of resources .append, and we can just simply append this resource. So in the same way that if we just had like a list of numbers, we, you know, and you did self.list of numbers.append 0, we can do self.list of resources.append and then just create an NFT and then move it, right? So move it into the list. So this looks a little confusing because it's like, well, what are we moving into? And basically this is just saying, hey, we're creating a resource and we're moving it into the list, right? So boom, now it's inside this list. So if we wanted to, we could actually read some information about this, and I'll show you that in a bit. Okay, so this next one, let's go ahead and I'll show you an example. Oh, one more thing I want to show you is how to remove from this, you know, how to remove from this thingy here. So let me go ahead and let's add a public function, remove resource, right? So let's go ahead and make this function. So how do we remove a resource from, you know, this array? Well, it's pretty simple as well. We can say self.list of resources. And then let me just refresh so we get the auto, like, whatever. Dot, we can look through here, dot remove at 0, for example, and it's saying loss of resource because, you know, this is another difference. We have to make sure that when we remove a resource, we have to do something with it, right? So we have to say, okay, let's let thing, let's move it into thing, and then let's just destroy it, right? So boom. Or, you know, if we wanted to, we could remove the resource and then just return it as a type if we wanted to as well, but we're not going to do that. We're just going to destroy it. So let's go ahead and deploy this contract like that. Let's go into transaction, refresh this page, and let's do some cool stuff. So let's say test.create resource. And what this is going to do, remember, test.create resource, it's going to go in here. It's going to append a new resource to our array. So if we go back to our transaction, let's call this function. Being weird. Thanks, Playground. So we can send this transaction. It says done. Now, theoretically, we should have some stuff in this side of this array. So let's go into a script and let's, log test dot list of resources. Now, I believe this might be a problem, right? Yeah. Oh no, yeah. So this is a problem because this is one more point I wanted to show you. Is that with resources inside of arrays or dictionaries, you can't simply print them, because what this is going to do is it's going to say, here, if I just do this again. Yeah, what this is going to say is, hey, it gives you a weird error here, but the reason it's failing is because it's saying, hey, this isn't working because you're trying to reference a list of resources and you would have to put them somewhere. So it makes it actually really difficult for you to read these. And we'll learn about how to correctly read resources much better when we talk about references during Friday's workshop. But for now, just know that it's hard to sort of read information about NFTs because you have to move them somewhere. So if, for example, we wanted to read information about an NFT in here, we would have to remove it, return it to the caller, like doing this, log it, and then move it back, which is super annoying, right? So you can all already tell that that's like going to be, really annoying to do. So we're not going to do that. But when we talk about references, we're going to talk about how to read this data without having to move it everywhere. Okay, cool. So let me just make sure I covered what I wanted to cover. So we added something, we removed something, and now we're talking about dictionaries. Okay, perfect. So this is arrays. Now let's go ahead and do public. Oh, and are there any questions about that, by the way? Nada. Perfect. All right. Cool stuff. So yeah, that is, man, I stubbed my toe earlier and now my toe is killing me. That's a very random fact. I don't know why I said that, but ow. Okay, so here we go. All right, so let's go ahead and make a list of resources inside of dictionaries. Thanks for sharing. You're very welcome. I think it's because I was playing soccer and like I kicked the ball and hurt my foot. Okay. So yeah, let's go into list of let's talk about dictionary of resources. Wow, it's getting very verbose. Okay, so in a dictionary, obviously, there's a key and then there's a value. So one thing with dictionaries is resources can never be keys. Now, not that like you would ever really want to do that anyway, because it doesn't really make any sense. Actually, it straight up doesn't make sense. But just to point it out, that you can't do like resource to like string. So the resources are always the values. So what we can do is we can map like string. Actually, you know what? Let's map the ID. Let's map the ID to the resource that contains that ID. So let's map integer to NFT. And just like arrays, the @ symbol has to be outside. So it has to be here. Okay, cool. Now we can go self.dictionary. Let me just copy this because it's getting so long. And then we have to move in an empty dictionary, just like that. All right. So let's go ahead and let's do. So this is for, let's just say, this is for arrays. And then we're going to do another one here. This is for dictionaries. All right. So we can say public function, add resource to dictionary. And in here, we're going to do a very similar thing to the array one, where we're going to create the NFT and then put it inside the dictionary like that. So let's go ahead and just say, let NFT. We're going to move in, a new NFT, and we can do that just by, the same way that we did it down here. So we create the NFT with, these parameters, just like that. And then we can put it inside this dictionary. So how do we do that? Well, we can say self.dictionary of resources at nft.id. So remember, we're mapping the ID of the NFT to the NFT itself. And then we're going to move in the NFT like that. Now it says loss of resource, and I believe that's because we're actually moving it and trying to reference it at the same time. Oh no, it might be because of that. Yeah, okay, cool. So I'll explain that in a bit. Okay. So ignore this error for now, but it's because, we created this NFT variable, we move the NFT into the variable, and then on the next line, we're saying dictionary of resources, we're going to map the NFT's ID to the NFT resource itself, and now the NFT will live inside of here. Okay, cool. Now, this is one thing I want to talk about. So remember I said that with resources, you can never, ever, ever, ever overwrite another resource, right? With structs, you can do that all you want. You can put a struct somewhere and then you can overwrite it if you want. That's totally fine. With resources, you can't do that because what if these resources were billion-dollar NFTs? We would never want that to happen. So what's happening here is it's giving us a problem. It's saying, wait a minute, we don't know, like we can't tell at compile time that nothing exists here, right? Because for all we know, self.dictionary resources at that ID could already contain a resource. And in that case, we would move the NFT in and it would overwrite it, which is really bad. So we don't want that to happen. So what we have to do is we have to add, there's two ways to do this. The easiest way to do this, but not necessarily the best way, but the easiest way is to add this little exclamation mark here. And what this says, I mean, look at this. Isn't this the coolest symbol ever? But what these say, this exclamation mark, is this says, hey, if something exists already at this right here, so dictionary resources at that key, then panic and abort the program and just don't do anything. So I mean, not don't do anything, but like revert everything. So just whatever we did, just get rid of all of it. But if something is not there, so if this is nil, then we can put the NFT in there and we're fine. So this ensures that we never overwrite anything, and that if something already exists there, we just don't, we just panic and say, there's a problem, please help. Now, there's another way to do this. And the other way to do this, that it's honestly like about a year ago, what I'm about to show you was the more common way. Nowadays, everyone just uses this one, but I'll show you what the old way was. So, and this is very helpful sometimes as well, by the way. So what you can do is you can say, now stick with me here. This is going to be a little confusing, but just stick with me. You can say let old NFT, and you can, and then here I'll show you exactly what I mean in a second. Let me just write this out. So look at this. I mean, this is getting a little crazy, right? We have moving going on everywhere. We're freaking out. Stuff is crazy. But yeah. So what this is saying is, first of all, we're going to look at self.dictionary resources at the ID. If something exists there, move it into old NFT, and then move NFT into this spot, because this spot should be empty now because we moved whatever was there into here. And then we handle this thing by destroying it. But you can imagine that if you want to, you can handle this a different way. You can say like, oh, if something exists here, then let's just return it and let's put it somewhere else. So this allows you, doing it this way, this allows you, I mean, it's giving us an error because I'm not returning anything, but this is allowing us to take what's here and move it into the return value, right? I'm not sure why it's giving us an error. It shouldn't be. Maybe it's because of this. Yeah, okay, I'll show you why. So this allows us to handle the case where something already exists there. Now, notice that this is just a quick side thing, that with NFTs, theoretically, this is never possible. Because what we're doing right now, and we'll talk a lot about this when we get into the actual NFT, because by the end of this bootcamp, we're all going to code out an NFT contract together. But just a little sneak peek, theoretically, this is never possible. Because think about what an NFT means. An NFT is a regular token that's unique and doesn't have any duplicates. That's why it's called a non-fungible token, because every ID is different. So theoretically, if you have an NFT with the same ID, then it's a fungible token. So it's not even possible, but you get the idea. Like you can imagine if we were not talking about NFTs and like some other example, this is just a helpful way to handle this. Now it's giving us this problem. I talked about this during the last workshop about how to handle optionals. So it's saying, hey, we expect an NFT, but you gave us an optional. So, of course we can just use our tricky little unwrap operator to handle that for us, right? Cool. So yeah, that is how we do that. All right. So that is how to add to a dictionary. And you can see that, you can see both these ways. So first I showed you can use this little cool exclamation mark. And then I showed you that you can use this right here. So that's all cool. All right. So the next one is going to be removing from a dictionary. So how do we remove from a dictionary? Well, let's look at it together. So let's just destroy old NFT so that we don't have any errors here. Alrighty. So public function remove resource from dictionary like that. Okay. And so in here, we're going to remove a resource from the dictionary. So let's go ahead and say let NFT, and we're going to do self dot, what is this? Dictionary of resources. dot remove, and then the key, right? So what NFT do we want to remove? Well, we can pass in the ID of which NFT we want to remove. We can remove that NFT, the NFT with that ID. And then, it says loss of resource, so we have to do something with it, right? So we have to destroy NFT. Now, this, usually you wouldn't be destroying it, right? Usually you would remove it and then return it, right? So we could also, if we wanted to, we can imagine this is called like withdraw NFT. So I'm slowly naming these functions. Like we can call this deposit NFT. I'm going to slowly name these functions to fit more with the NFT example that we're going to work through together in a week. So you can imagine this is depositing, and then this is going to be withdrawing an NFT. So let's withdraw an NFT. We can return a @NFT type here. So what we can do is we can just return the withdrawn NFT, just like that. Now, if we refresh this page, because it's being weird, it's going to tell you, hey, mismatch types, expected this, got that. So of course we could fix that with the little exclamation mark here. Or what we could do is we could add a panic, because most of the time, usually if you're like a pretty experienced Cadence developer, you always want to make sure that you want to use the exclamation mark as little as possible. And the reason for that is because if you're writing programs in Cadence and you just use this, what's going to happen is if this ever actually gets triggered, the error message is going to be like, hey, found a non-nil unwrapper, and then you're like, wait, what the heck? Like, what does that mean? Where is that happening? Because if you're using this all over the place in your whole contract, you have no idea where it's actually getting a problem. So you always want to use panics as much as possible, because in a panic, you can actually say to the user what went wrong. So we could say like an NFT with this ID didn't exist. And now this is a lot more helpful, because if this NFT didn't exist, the person making this call would know that it's because an NFT with this ID didn't exist, right? And so, of course, this double question mark also unwraps the optional, and now we're totally fine. So that is, that is depositing and withdrawing from this dictionary right here. So I believe that is all I wanted to show you in this example. Oh, one quick thing. So you might be asking, well, why can't we do something like this, where we, instead of using .remove, why can't we just access it like this, where we just say like ID? What's wrong with this? And the reason for this is the reason you can't do this syntax is because it'll say like, hey, cannot move nested resource. And so for some reason, Cadence doesn't like this. It doesn't like when you reference a dictionary with a resource in it, with the bracket notation. You always have to use .remove. That's just a little thing that I've learned throughout my Cadence time. So yeah, and we already know what this error message is, so I'll just put LOL. All right. So does anyone have any questions about depositing and withdrawing from either a array or a dictionary? Or just resources in general? All right. And also feel free to unmute whenever. So that is, yeah. So what was the quest for this one? Write your own with contains an array. Okay, we already did this. If we want to, we could get into references a little bit, but I'm sort of hesitant to do that. Although we actually might have to. Yeah, maybe we should talk about references a little bit. Actually, yeah, this chapter is pretty small, so we should do this together. Yes. Okay. So return a reference. I just want to see what I did here. Okay. Yeah, okay, cool. We're going to do this together. All right, so everyone's doing good? Good. Cool. So I'm going to remove some stuff here. So I'm going to get rid of the array example, and I'm also going to, I'm going to get rid of all the array functions, because I want to get into references now a little bit. So I'm just going to slim this contract down a teeny bit. Okay. So, all right, awesome. Now, this next part of the video is going to be talking about references, which is also like a very, very important part of Cadence. So this workshop's definitely a bit packed, but I hope I'm not losing everybody with these examples. Or maybe you're all just legends, who knows? Okay, so remember that the problem is that we want to read information about these NFTs, right? we want to, I want to say, you know what? I want to get my NFT that has ID 5 and I want to read its name, right? I want to see BZ because I love BZ, right? The problem is that right now, to read this NFT, we would have to withdraw it, read the name in the transaction, right? Or the script, and then we'd have to put it back by depositing it again. And that's super annoying, right? We don't want to do that. So we want to find a way to leave the resource inside of the dictionary, but still find a way to read it. So that's what we're gonna go over now. So we're gonna make a function called borrow NFT. Now, usually if you look at like any NFT contract, and remember, like I'm saying, I'm trying to slowly work our way towards an NFT contract here. So if they use the term borrow. Now, borrow means you're getting a reference. So let's borrow, and we're gonna ask, hey, we want to borrow an NFT with this certain ID, and then we're gonna return a reference to an NFT. So look what I did here. Quick note. So resources always use this @ symbol, where references use the and symbol. So you know that, hey, this is a reference to an NFT, okay? All right. So we're returning a reference. Now, how do we get a reference? Well, let's say let reference equals. Now, in order to get a reference, remember, you have to use the reference symbol, and we want to get a reference to self.dictionary of resources at ID. Now, let me just zoom out a little bit so we can see this better. And let's just, God, for some reason, I don't know what it is, but the playground has been really buggy lately. I don't know what happened, but it's super annoying. But okay, cool. And then let's just return the reference, right? So what's happening here is we're getting a reference to self.dictionary of resources at the ID. I'm returning the reference, but we're getting an error. And the error says expected casting expression. So the reason for this is because whenever you want to get a reference to something, you always have to specify the type. So we have to say as a reference to an NFT. And this says we're getting a reference to this thing as a reference to an NFT. Now, if we had put like, reference to string, it's going to give us an error, right? It says mismatched types, got, reference to an NFT, and you were expecting a string, right? So it tells you right off the bat why it's wrong. But we can say, you know what? Nope, we want an NFT, and then we're returning that reference. So this is really helpful because let's deploy this contract and let's start playing around with this stuff. So what we want to do is we're going to first deposit an NFT into this dictionary. Then we're going to borrow it. So we're not gonna have to withdraw it at all. We can just borrow it and read some of its data. So let's go to a transaction. Let's refresh this page here. And I believe I don't know what we called this function. What do we call it? Deposit NFT. Right, so let's just call this function, and then it's going to say done, right? So let's send that. I think we just have to refresh again. Yes, okay. So it says done, right? So now theoretically, inside our contract, an NFT lives inside of here with ID 0. All right, cool. So that lives in there now. So what we can do is we can call this borrow NFT function with ID 0, right? Because that's the ID that we passed in, and we can get the NFT. So let's go to our script. And let's just refresh again. God, it makes it so hard to teach. Okay, so let's say let reference equals, and with references, we can use equals. We don't have to use move because we're not moving anything, right? So let reference equals test.borrow NFT with ID 0, okay? And then we're going to log ref.name, and that's it, right? So we don't have to like destroy this because it's just a reference. We can say execute. And look, it logs BZ. Yay! So we read information about our NFT. We can also log the ID, ref.id, and we can also log ref.holder, which are the two things that are inside of there. So we can execute, which is all cool. Yay, so we get a bunch of information. So that's all sweet, right? That's all awesome. All right. So that is basically an introduction to references, and we're probably going to get a lot more complicated at some point in time, but this is what I taught you inside of this chapter. So this was a pretty short chapter on references because I didn't want to completely overload you with information. But I do want to go over some, really helpful things about resources that are pretty cool. So one thing that's really helpful about resources is right now we're passing in an ID to this NFT, right? We can actually get rid of this. Let's get rid of these IDs, right? And let's get rid of all these IDs. But we need a way to give this NFT a certain ID. But because it's an NFT, we want to say, you know what? We want to give this an ID that we know for sure is never, ever, ever going to be the same. Now, resources have this built-in thing called UUID, which is a unique identifier. So we can say the self.id equals self.uuid. Now got uint, okay, and the UUID is actually a uint64, so we have to change the type for a second. And this also has to be, yeah, what we would theoretically have to like pass in the ID here, like that. Hold on, it's being weird. Oh, because we changed this to uint64 as well, and this one as well. Just changing all these to uint64. Okay, perfect. So what UUID is it's a unique identifier that's never, ever, ever the same for any resource on the entire blockchain. So every single resource on the blockchain has its own unique UUID. So it's perfect to use as the ID for the NFT resource, because if it's never the same, we know this will truly be a non-fungible token and not a fungible one. So just wanted to point that out. Now, another cool thing that we can use about resources is that they have an implicit owner field. So you'll notice that if I try to declare a field called owner here, it's going to actually tell me cannot declare field here owner. And that's because NFT resources as a whole already have an owner field. And the owner field is the person that owns the NFT. Or sorry, I keep saying NFT, but resource in general. So, you know, it's the person that owns the resource. So what we can do is, I think this will work. So if we go into the script here, we can actually log, hold on, let me just refresh the page again. We can actually log ref.owner, right? So you'll see that when I do dot here, it's telling me there's an owner here, even though I don't even have an owner in here, right? That's because it's already present because it's a resource. We can say ref.owner, and then dot address like this. And now it says value of type public account question mark, right? So we can unwrap the optional by doing that. And now let's just refresh the page. Yeah. So we can execute this, and look what it says. It says ref.owner. So ref.owner is the person that owns this reference. Now remember, the reference is pointing to an NFT, right? It's pointing to an NFT right here. And then it's saying get the address of the owner. Now look at the owner here. It's 0x1. Why is that? Well, it's because the person that quote unquote owns this resource is account 0x01 because it's deployed to this account. Now, what we're going to talk about in future workshops is that when we start talking about account storage, as you've read during chapter 1, a lot of data, like the cool thing about Cadence is that data is actually stored inside of a user's account. So even though right now all these NFT resources are being stored in the contract, what we're going to actually talk about next time or later down the road is the fact that we can actually store these NFTs inside of a user's account. And then something like this is really helpful because this will allow us to get a reference to an NFT and then see who the owner is, right? Which is super cool. So just wanted to point that out for next time when we start talking about, you know, some cool stuff about that. And one more thing before we wrap up here. Of course, you can ask as many questions as you want in the chat. But one other thing I want to mention about resources is that, of course, they can have functions as well. So if we want to say public function change name to a new name, like this, we can say self.name equals the new name. And now we have to make sure this is var, because remember, let is a constant. So let's just deploy this. And what we can do is let's deposit an NFT, and then let's borrow reference to it and call change name and see what happens, right? So let's go to our transaction. My God, it's so aggravating. Oh, it's because we have to pass an ID here. So remember now, wait, do we actually have to deposit at, oh no, this should be NFT.id. Yeah, so we don't actually have to pass in anything. Yeah, okay, cool. So let's deploy this again. I made a mistake here because before it was just giving me problems with the types, but NFT ID is just, you know, it's fine now. So we deploy the contract. Let's deposit an NFT. Okay, so we can run this transaction. It says done. Now, what we can do now is go to a script and read some data about the reference. So, oh, now this brings up, okay, this is a very interesting point. So remember before when we were depositing the NFT, we were hard coding the ID to be 0 so we could read it really easily, right? Now there's actually a problem because the UUID, we don't actually know what the UUID is. So we have to have some way of figuring out what the heck keys this dictionary stores. So we can actually do that by making a function called let's say get IDs, and we can return an array of UN64s. And this array is basically all the keys that this dictionary has, so we know how to access it. So we can return an array of it by saying return self.dictionary of resources dot keys. And dot keys is it returns an array of all the keys so that we know which IDs to call. So let's redeploy this really quickly. Let's go to our transaction and run the transaction. We might have to refresh. So send the transaction. It says done. Now we can actually, let's try and get the IDs of what's stored in that dictionary. So let's make a new script and let's import test from OXL1. Let's do public function main. And this is going to return an array of UN64s. So let's say return test.get IDs, just like that. So if we execute, it's being weird. Okay, execute. So look at this. It says it's a type of array, and the values it's formatted weird, but it says, hey, the value is 0, right? So if we were to mint another one, let's mint another one really quickly. Deposit, right? Let's run the script again. So let's clear this and run it again. Oh, look, now there's multiple. So there's 0 and 1. Now keep in mind, for some reason, like on the playground, it's incremental. So it's 0 and then 1 and then probably 2. Like if we mint another one, it's probably going to be 2. So let's mint another one. Yeah, so like 0, 2, 1. But in the actual Flow blockchain, these UUIDs are like long numbers. Like they're like, they're like 1, 2, 7, 4, 5, right? So these UUIDs are very unique. But in the Flow playground, just because it's an emulator, it's incremental, but don't count on them ever being incremental because they're not. But anyway, now we know the IDs of what we can call. So an NFT with ID 1 exists, with 2 exists, with 0 exists. So let's go ahead into our script and let's refresh this page just to make sure. And instead of just passing in a hard-coded ID, let's actually pass in the ID through the script. Just like this. So let's go ahead and log the ref.name. So we know the NFT name that we're looking at. So let's log 0, right? Execute, boom, we get BZ, right? And if I run 1, it's going to also log BZ because if you look at the contract, we're hard coding the name BZ for every single NFT. But, you know, you could pass in these if you wanted to, right? You could pass in a name and a holder if you wanted to. Okay, so this is all cool. So we logged the name. Now, the whole point of this was that we wanted to be able to call change name. Now, of course, we can't do this inside of a script because the script can't change data on the blockchain. So we have to do this in a transaction. So let's just make a new transaction. Let's paste some stuff in here. And let's get a reference. So let reference equals test.borrow NFT. And the ID, UN64. And we can pass in this ID up here, UN64. Oh, this is supposed to be ID. So let's refresh the page. And what we can do is we can log ref.name. Then we can say ref.change name to a new name. Let's just say SWT. And then we can log ref.name. Right? So let's see what happens. So when we go to, let's just put in 0 and let's send the transaction. And look what happens. So it changes it. So BZ and then SWT. So perfect. It changed the name. And now, of course, you know, this persists. So if we go to a script again and we do 0, boom, it's SWT. So this is proof that it actually changed. So of course, resources can have functions on them. And that's about it. So I guess like the concluding point here that I also want to mention is that sometimes, and this is going to segue into the next lesson, sometimes this is bad. Because what if we only want the owner of this NFT to be able to call a function? So what if we say like public function, you know, change, I don't know, like for example, what if we want change name to only be called by the owner of this NFT, right? This is really bad because right now we're returning a public reference to the NFT to change the name. So any account can change this name if they want to, which is pretty bad. So during the next workshop and during the later parts of chapter 3, so days 4 and 5, you're going to learn about resource and struct interfaces, which are going to allow you to control who can call what variables and functions inside of a resource and also a struct. So it's in these chapters, we're talking about both resources and struct interfaces, but all the examples I use are always for resources, but structs are pretty much the same exact thing. So if you're wondering about structs, it's almost the exact same thing. So yeah, that's what we're going to talk about in the next lessons. So I hope that was helpful. So we talked about resources, references, and resources inside of both arrays and dictionaries. Woohoo! How is everybody? Totally lost or feeling like a champion? Mind blown. I love it. I hear my brain crunch. That's great. Yeah, this stuff for sure. A lost champion? Oh no. It sounds like I lost a few people. Oh no. A few steps above lost. Yeah. Yeah, so I'm curious, like, where is everybody? Like, if you are lost, I'd be happy to answer any questions you have. But I do agree that it's almost like, you know, I can always do my best to, you know, show you, but it's the best way to learn is always to just play around with it. That, you know, that's always the best way. Yeah. No, that's definitely tough because the first half was talking about like an introduction to resources and all that. It sounded fantastic. I'm glad. Yeah. So dude. So this is all recorded on YouTube. So I'll send the link to the recording so you can catch up on the first half. Yeah, you're welcome. I always send the links to the recordings in the announcements channel for Emerald Academy, so in case anyone's curious about where to find them. Also, this is a side note, but Zero, your work on the pre-mint was awesome. Was so awesome. I saw it earlier, and I meant to respond, but I just didn't have time. But I'm gonna get back to you on that. That was super cool. That will help a lot. Yeah, no, Zero. Like seriously, I honestly really hope that I can keep you involved because I loved it when I saw that. Hi Jacob. Which of the common mistakes I can make with handling? Okay, that is a fantastic question right there. So common mistakes. So I would say that common mistakes. That's a really good question. I would say common mistake number one is this one right here. So people don't understand that I see this all the time. When there's resources inside of a dictionary, people always try to pull out the resource using bracket notation because they're used to this. So like, for example, pulling it out with ID, but you can't do that. You have to use the remove function. So that's one thing that I would definitely be aware of, doing that. Another thing is that with withdrawing again, people always get into this problem where they try to remove the NFT and then they don't know why it's an optional. And you have to remember to unwrap the optional here. That's definitely a big one that I always see. Another one is depositing. So right here, I'll show you how I usually do it. When you deposit or put an NFT inside of a resource here, or inside of like what's it called? Inside of a dictionary, you have to wait, why is there an error here? Oh. You have to make sure that it'll give you this error. It says cannot assign to resource type target, consider force assigning or swapping. You have to make sure to put this little exclamation mark here to say that, hey, if something exists here, don't do this. But if something doesn't, then we can do this. So putting that as well, I think, is also really important. And of course, another really important concept is that, like, you can only ever create NFTs inside of a contract. So unlike structs, you can't just say, like, let thing and then create an NFT like that. So you can't do this because create can only be used inside the contract. So those are the big ones, I would say. I think most people usually get tripped up when they start getting into resources in dictionaries. That's usually where people start to struggle. So if you can understand that, I think that's really good. And of course, the loss of resource error. That's like the biggest error as well. People don't know what loss of resource is, and it's really just because they're not handling the where the resource is supposed to be going. So you either destroy NFT, or you return it. Return NFT, something like that. As long as you're moving the resource somewhere. And like I said, next week, I think it's so. What do we have? So the rest of this week is struct interfaces, and what's on day 5? Access control. Oh, that's a big one. Wow. Okay. Yeah, but during chapter 4, I believe, is where we start account storage. Yeah. So chapter 4 is account storage, and that's where resources become super flexible and cool.
So you had mentioned that you can.
Oh, sorry. What did you say, Sport Monkey? I think you cut out. I think you're muted.
Is my stuff coming through now?
Yes, I can hear you now.
Okay. You mentioned that you can put a function into a resource, like a verb, basically.
Yep.
Can you put more than one function? Like, can you put nested functions into an NFT?
So yeah, I can put as many functions as I want. Like that.
Okay. Would that be gas efficient? Or I know gas doesn't matter as much in flow because costs are lower, but like for if I wanted to do a series of actions, could I put them into an NFT and then just pass that NFT around, almost like in Python with modular code?
Oh, of course. Yeah, that's one of the most common use cases. In fact, let me actually, I think this would be like a good sort of like ender, but let's actually go ahead and look at the actual NFT contract that is on Flow right now. So let's pull this into the playground for a second. So this is an example implement. This is literally what like an NFT on Flow looks like. So hold on. Let me just configure this really quickly. I know this is kind of annoying to watch me do this, but hold on one second. So that one more. You guys don't have to understand what this is, but let me just do this so that it gets rid of all the errors. Deploy that, then please deploy, please. Deploy. Okay, nice. Now let's just change these. So it's gonna go away. Okay, perfect. So this is an actual NFT contract. And look at the NFT here. So this is a NFT, and we're going to be building this, by the way. So when we're done with the bootcamp, but this is the NFT resource that they use. There are some variables in here, like an ID, right? A name, a description, a thumbnail. I don't even know what thumbnail is, but and there's functions in here like get views, resolve view. So this is part of the metadata standard if you've heard of that. And then here's another resource, right? So this is a collection. So this collection stores NFTs inside of it, and look how many functions are in here. There's a withdraw function. There's a deposit function. There's a get IDs function. There's a borrow NFT function. By the way, I'm such a good teacher that, look, we actually implemented these today. Haha. So sneak peek. And then, other functions. So you can see Support Monkey. There's a bunch of functions in here, and it's totally fine.
Beautiful.
Yeah. So yeah, I mean, yeah, like for the record, like today I taught like depositing, withdrawing, borrow NFT, get IDs. Look at the actual example NFT contract. That's all right here. So we already have like I'd say 30% of the contract done. And then there's a bunch of other cool stuff, but we'll get into that in a bit.
One of the things I will be most interested in is the implementation of these contracts to the web. Like, how do I have a website right now. Like, I know how to make a button on a website, but like, how do I connect our, a contract or a structure or these things that we're making? How do I connect that back to the quote real world?
Yep. So this bootcamp number 1 is all about cadence. So you'll see that at the end of chapter 5, like the main, like this is the end of the bootcamp. You can see it's the full NFT contract. So this is literally what we're going to be doing. And then bootcamp number 2, which is the next one we're going to do, probably about like a month out, maybe. That's going to be all about the Flow client library, which is actually getting this contract that we built in this bootcamp onto a web.
That's awesome. I can't wait.
Yeah. So if you're curious about actually connecting the blockchain to a web app, we're going to work through pretty much everything you need to know during the next bootcamp. So
not to be a shizer and to keep talking, but like, let's say I wanted to be an ultra go-getter, because you said about a month, and you said it takes about 2 to 3 weeks minimum for Flow to validate your contract and allow it. So if somebody wanted to be a real go-getter, they could maybe write their contracts, submit it to Flow, and then work in the next bootcamp to actually implement what they submitted?
Yes, although I would say that, like, during the next bootcamp, we're going to be testing a lot, and like, you don't want to be testing with your mainnet contract, obviously. But yeah, like I would say like you could write your contract and then, spend all of next bootcamp working on testnet. And then after you learn about testnet, you can try and work on mainnet, because you don't want to mess up when you're dealing with mainnet.
Sweet. Thank you, as always, for humoring me.
Yeah. All right, so that's the end of this. Just a few announcements on my end. So yeah, we actually have, because I like to humor myself sometimes, and I think I'm funny. So we actually have a Minecraft Emerald Challenge coming up next Saturday, so March 12th. So if you've ever played Minecraft before and you're addicted to it like I am, we're going to have a whole party in Minecraft. People have already sponsored the event. BZ is actually going to be sponsoring from Basic Beasts. We have people from Dugout Dog sponsoring. I'm pretty sure the .find project is going to sponsor. So we have people from all over the Flow ecosystem giving tokens and packs to sponsor this event, which I think is hysterical. And all the sponsors are going to have their like project logo built at the spawn point where everyone's playing around, so that it's like a really cool like Flow ecosystem Minecraft thing. And whoever wins, we haven't come up with the prize structure, but the people that win are going to get packs, tokens, a bunch of cool stuff. I think it's going to be really fun. And of course, because, we are Emerald City and we do have to do something productive, if you do win, you have to like write your own smart contract, but it can literally be like a hello world example. And all of you in here have already done that in the bootcamp. So I really encourage all of you to participate in this bootcamp, or in this Minecraft challenge if you played before. I think it's going to be really fun. So yeah. And the Emerald City next town hall, if you don't know much about the town halls, if Emerald Academy is like a subset of Emerald City. Emerald City is like the overall DAO that is education, building, governance, all that. So that's like the most important meeting every 2 weeks. So on Saturday at I believe, when is it? Saturday at 8 a.m. PST, we're having the 6th town hall meeting where we have like a bunch of people show up. We have some really cool discussions about the Flow ecosystem, where Emerald City's going, and all the stuff we're doing. So if you're interested in Emerald City as a whole and getting involved in a DAO, I really recommend coming to this town hall. And that's all I have. So I'll finally shut up. So sorry, I ramble a lot, but yeah, thanks everybody. Woohoo! You're all doing great. And don't get discouraged by chapter 3. It gets hard, but that's the point, right? Like the point is to learn, to keep struggling, to keep doing great, and I'm here for you. So thanks everybody. I'm waving at my screen even though you can't see me. Bye. Thank you.
Later.
Later. You're welcome. Thank you. No pain, no gain. Facts. All right, I'm actually leaving now. Bye.